Hello and welcome to the lectures on solar power systems. In this video lecture, we are going to discuss what is maximum power point tracking, MPPT, the maximum power point tracking. We are going to understand the concept of maximum power point tracking in PV systems. As the name is indicated, MPPT, that is, we are maximum power point tracking. It means that we are going to track the maximum power. What does it means? Let's say here you have a PV module. Let's say this is the PV panel, or you say it solar panel or PV module, and here you have the sunlight. Sun rays are there on the PV panel. Now you know that the sunlight intensity changes throughout the day. At 12 noon, at the noon, it is maximum. So the sunlight on the panel is maximum, but early in the morning or early in the evening or in the evening, these sunlights are reduced on the panel. Okay, so it means that the solar radiations on the panels is varying at every instant. Okay, so maximum power point tracking means that we are going to extract the maximum available power from the solar panel at every instant of time. Now what does it mean? This is a very broad concept. Okay, so keep your eyes and keep your brain open to understand these things, because I am going to elaborate different things, and then we will conclude that how the maximum power point tracking is done. So first thing, I will discuss with you that you know what is power. Power means, power is actually the product of voltage and current. And what is meant by maximum power? It means that this product is maximum. Okay, now this is the PV panel, and obviously let's say if you connect a load here, let's say you are connecting a fan, a DC fan, directly to the panel, then what will happen? It will start running and it will work. So obviously there will be some kind of voltage here, and there will be the current flowing I. Now the product of this voltage and current is what that is known as the power, which is going into the fan. But when you have to do the maximum power point tracking, then it means that now this is the load and this is not in our control. Load has some specific resistance, which we can say that this is our load. Okay, now load has resistance. Is this resistance in our control? No, the load resistance is independent. Okay, now now is this sunlight under our control? No. Whatever will be the sunlight, it will be falling on the PV panel, and this DC fan will be powered up. So under this mechanism, we cannot extract the maximum available power from the panel. Whatever the voltages are, whatever the current will be, there is a load, and it will run the fan. If let's say at 12 p.m. noon, the fan will be running at maximum speed. Why? Because at that time the available energy is more and the voltages are more. Obviously, fan speed depends on the voltage. Or at 8 a.m. in the morning, the speed of fan will be lesser as compared to the 12 a.m. I'm saying that this load is not under control. Whatever the DC fan has, the internal resistance, it will be there, and if you connect it directly, it will power up this load. Now, this mechanism is not fit for maximum power point tracking because it is possible that at 2 p.m. the solar panel can generate, let's say this is the PV panel of 100 watts peak. Peak means the maximum power the solar panel can generate is 100 watts. This is the rating of that panel. Now let's say at 2 p.m. this solar panel is receiving sufficient sunlight that it can provide you 75 watts. Okay. And but what you are doing, your load, although this load is the 75 watts load, let's say, but it is not actually drawing this much power from this panel. Let us describe or understand it in a different way. As I told you that I will be explaining different concepts in front of you. I will be putting them because this MPPT is a very broad, or it is not a broader topic. It comprises of a broader concepts. Okay, let's say this is the panel and this is rated at the 100 watt. Now let's first draw the IV curve. Now what is IV curve of a panel? This is what known as the IV curve of a solar panel. How it is made? Now look, this is the panel and having 2 points, the positive and negative. What we are going to do, we are going to connect a variable resistance here, and we are going to measure the voltages, and we are also going to measure the current amperes. At first, we set this resistance to, so this is the variable resistance. We set this resistance to 0 ohms. What will happen? The maximum current will flow. We say that at this time when the resistance is 0, it means that there will be the maximum current, and let's say that current is known as, this is the I and this is the V. That current is known as I short circuit, the maximum current. At that time, the voltage here is 0. So this is the voltage is 0. So this is one of the point which is known as ISC. Now you keep on increasing the value of this resistance up to the point that it is very high value and the current here is almost 0. Then at that instant, what will be the voltages here? The voltages will be the maximum possible voltages which could be at this point at that instant. Now what is at that instant? Let's say at 1 p.m. you are plotting this IV curve at 1 p.m. 1 p.m. Okay, what happened? First you have zero resistance, then you kept on increasing the resistance. What happens if you increase a little bit of resistance? there will be the voltage drop. Resistance is low, the voltage drop is less, but the current will be high. Okay, this is now you further increase the resistance. More resistance, it means that more voltage, but current is still low. You keep on doing this, you keep on increasing the resistance till there comes a point that now the current is almost zero, and we are left with only the voltage across this high value of resistance. Now that voltage is known as the open circuit voltage, that is VOC. So the typical curve we get, if you do this, we get this type of typical plot at 1 p.m. You can do this for any time, for any instant of time. Now what is power here? You can see that here the voltage is 0 and current is maximum. Here the voltage is maximum but the current is less. But there is a point that at which the IV, the product, is of the maximum value. That point is known as the maximum power point. This is the MPP. This is the maximum power point. At that instant, the product V and I is maximum. Now look. If you have the resistance, let's say resistance is much lesser. There is a high current, but voltage across that resistance is less. It means that the power at that instant is less. If you keep on increasing resistance, but there comes a point, there comes a specific value of our load at which the product VI is maximum. Now that point is known as the maximum power point. And what we have to do is we have to track this point. And let's see here, you have a curve which is known as the power curve. This is power here. Okay. So at this point, the power is maximum and then it is lower. So this is what the maximum power point. Now look back. I give you an example of a fan. Okay, we connected a electric fan here, DC fan. Now DC fan has a load resistance which is not in our control. So there will be no such kind of the maximum power point tracking exist. Now what happens, how to find out this point? This is very important. Let's see the whole system to understand what are the sensors involved and how we do this. Okay, let me erase this. As you know, the load is not in our control. Okay, so we do not connect a direct load with the solar panel in order to do maximum power point tracking, because let's say if the load is higher, if the load is lesser as compared to the required value of the resistance, what you will do, you must have a battery storage such that whatever the power you are extracting, you should saving it inside your battery. Now look, it doesn't mean that if there's a battery only and that system becomes a maximum power point tracking. No, never. What happens is that you have you have a buck boost, or I may say this is step up, step down. There we are using a step up, step down DC to DC converter, and here you have a battery. Here you have a battery, and this is the current regulated as well. It is current regulated, that is this this is the charging current is controlled, okay, and here you have this. But now this power converter, which is the buck boost or step up, step down converter, this is not only the current regulated converter, but it has also built-in MPPT algorithm. The maximum power point tracking algorithm is also built in this buck boost converter. Now what happens? As you know, if you increase the amount of current draw from solar panel, what will happen? Or if you decrease the current from the solar panel, what will happen? As I told you, we have just seen the IV curve, and there was a point which was I short circuit, and here we had a point which was V open circuit, and we have such type of IV curve. Now what happens? This buck boost converter behaves as a variable load to this solar panel. As I told you, if you increase the load resistance, the voltage here will increase. If we decrease the load resistance, the voltage here will decrease. So what happens? There is always the check of the power flow. Okay, here you have the current sensor and you have the voltage sensor, and inside the algorithm, inside the microcontroller which is built in this power converter, there is always the product is done of V and I. And what happens? Now look the magic. Now if you increase, let's say if this power converter is first increasing the charging current and comparing the values and comparing the product Vi. If the product Vi is decreasing, then what it will do, it will decrease this charging current, and it will either move in this direction or in this direction, such that it actually captures the point at which this product is maximum. Okay, so current and voltage sensor are present here at this side, and what is it? It is doing one more thing. It is also regulating the voltages. Charging current is controlled, as well as V output. Here this V output is regulated to 13 or 14 volts, because you have to charge the battery. But the voltage here, this V input voltage is this input voltage, and this current, the I input, it is always done in the product. There is a built-in microprocessor which compares the value of the power. What it does, let's say it is first increasing the charging current, it means that the voltages here will decrease and current here will increase, but it is going there. It will see that the product is less. What it will do, it will start decreasing this charging current. What will happen? The voltages here will rise, but the net product of Vi is increasing, and at that point it is more. If it is further decreasing the charging current, then this product starts to decrease. So the built-in microprocessor which is taking the values from these current and voltage sensors compares this value of the power, and what it does in this way, we track the maximum power point. Hence, from the same PV panel, we are able to extract maximum power at any instant, let's say at 1 p.m. If there is no such algorithm implemented, there will be only a battery charger, and this charging current will always be tried to kept maximum, and there will be no such PowerPoint tracking. But here what we are doing, we are at this at the input side, what we are doing, we are looking for that value of the voltage and current such that the product P is equal to Vi is maximum. This is what known as the maximum PowerPoint tracking, and this is what, this is actually the solar charge controller. And this solar charge controller, if it is an MPPT based solar charge controller or simple charge controller, it depends. If it is simple, then there is no such tracking of maximum power point. Whatever is the available power, whatever is the power required by the load, it will be extracted from the panel, and there will be no such lookup for the maximum power point. I hope everything is clear about what is maximum power point tracking. Now you can look for different algorithms. There are different MPPT algorithms like perturb and observe, and different algorithms. You can do a further research on Google, but this is not the part of our this lecture series on solar power generation. My aim was to give you an idea that what is MPPT and how these such things work. Thanks a lot.